Okay, so this is the first class for a new topic, differentiation of AS. You have done a little bit of differentiation in your IGCSE as well. So in your IGCSE, you learned how to differentiate a simple function and then finding the equation of tangent and normal. Equation of tangent, normal, and the turning point. Finding the turning points. These are the things you have done in your IGCSEs. For the O level people, you have never done this before. Differentiation is completely new for you. So don't worry, we are going to do everything from the basics, everything. And these three things definitely would be good, and you have many more things as well. So buckle up. So first of all, what is differentiation? You differentiate a function. Differentiate, both of them are the same meaning. Differentiate, derivate, rate of change, not rate of change. Differentiate, derivate, both of them are the same word. So what do you do first of all if you have the original function y or fx? When you differentiate this thing, differentiate or derivate is the same thing, okay? You get the derivative function, the differentiate function, which is now represented by y dash. You can write y dash, or you can write f dash, or the dy by dx. All three of them represent the same thing, dy by dx, y dash and f dash. This is a dash, not minus 1. This is a dash, like this. And this is the original function, y is equals to fx. So first of all, we have to learn how to find this derivative function. If you have the original function, what are the rules, what are the formulas that you use to differentiate your the terms in your equation and find the dy by dx. So the first formula, I will get to the basic parts as well. What does it represent and how do you use it further? But the first thing that you need to learn is the formulas, the initial formulas. For example, you have y is equals to x power n. Power n means it can be any power. It can be 1, 2, 3, 4, any integer power or decimal or any power, negative as well. If right now they're asking you to differentiate this thing, so what do? So your y becomes dy by dx, because now your function is now differentiated. And what happens? The power comes down. N is your power. It comes down and multiplies with the term. And x multiplied by n minus 1. The power of x reduces by 1. So if it is x square, the 2 comes down and it becomes 2 minus 1, which will be 1. So 2x. So the derivative of x square will be, let's do an example. This is the basic one. If they ask you to differentiate x square, simple x square, y is equals to x square. So the derivative will become dy by dx will become, the 2 will come down. Just look at the formula that the n power, whatever the power is, it comes down and multiplies, and the power reduces by 1. So 2 will come down and multiply, and 2 minus 1 will be 1. The power reduces by 1. This is the basic formula. Then let's do another one. If you have y is equals to 5x power 6, so what happens in this case? The derivative y dash or the dy by dx. The 6 will come down and multiply with 5. So 6 multiplied by 5 will become 30. And x to the power of 6 subtracted by 1 would be 5. The power reduces by 1. So the power comes down and the power reduces by 1. This is your answer. Then the third example, let's suppose you have y is equals to under root x. Under root x means that it has a power of 0.5. Now if you want to find the derivative, the 0.5 power will come down and multiply. And x power will be reduced by 1. So 0.5 minus 1, zero point 0.5 minus will be minus 0.5. So this is your derivative. If you have y is equals to minus 20 x power minus 3. If you want to differentiate this thing, the y dash will be the minus 3 will come down will come down and multiply with minus 20 with the coefficient. So minus 3 times minus 20 will be 60 plus 60. And x power will be reduced by 1 furthermore. Minus 3 minus 1 will become minus 4. So these are some very simple examples of how to differentiate your function. The power comes down and multiplies with the coefficient, whatever if there is, and the power is reduced by 1. This is it. Then another rule, a simple one that you will need is y is equals to a constant. If let's suppose you are differentiating a constant, so the derivative of a constant, it is always 0. If it is million, if it is minus 5, minus 10, 6, 14, if it is a constant, the derivative will become 0. So now let's suppose you have an equation. They have given you y is equals to 4x cube minus 7x square plus 6x plus 2. They're asking you to differentiate this thing. So what would you do? The y dash will become, we know the power 3 will come down and multiply with 4. So 3 times 4 will become 12 and x power will be reduced. So 3 minus 1 is 2. Then the 2 will come down and multiply with minus 7. So 2 times minus 7 is minus 14. And x power will be reduced by 1, which will be 2 minus 1 is 1. Plus the power of x right now it is 1. And now if you would differentiate, the 1 would come down and multiply with 6, so it will remain 6. And x power would become 1 minus 1, which will become 0. And plus 2, 2 is a constant, so the derivative of 2 is 0. If you simplify this thing further, you are left off with 12x square minus 14x plus 6. This is it. So you can see that if you had the 6x, only 6x, it became 6. The power, the x completely gets removed. It's now a constant. So whenever you have x to the power of 1, the derivative will just be the coefficient. It was 6x. After differential, it becomes 6 only. Okay? Any questions, anyone? संची समझ आ रहा है? मुनीब?
जी सर।
The first thing that you need to learn is to get proper hold of these formulas so that you can differentiate. Once you know how to differentiate, the next part is a few more steps and you do the applications. What do you need further? For example, if you have y is equals to uh 7 upon x square minus 6 x4 plus 3. Now if your equation is not in the perfect form, is in the variables are not arranged properly or they've not written down properly, so take another step, do one more, two, three more steps and simplify it into a better format. So what am I doing right now? Look, first I'm moving the x square above, so this becomes 7x to the power of minus 2 minus 6x power 4 plus 3. Now I can differentiate it. Now it is a much better format. So y derivative will be the minus 2 will come down and multiply with 7. So this becomes minus 14. And x power will reduce by 1. So minus 2 minus 1 will be minus 3. Then 4 multiplies with minus 6. So this becomes minus 24. And x power 3 minus 4 minus 1 is 3. And 3 is a constant, so derivative is 0. This is your answer, the derivative. So let me do one more example for you people. And then I'm going to give you some of them to differentiate. If we have x square minus 1 upon cube root of x. Now look, first of all, in this example, you will have to simplify the terms, separate the terms, use some indices. So what can I do? On the first one, I can expand the top bracket, the numerator. So this becomes x cube minus 1 upon cube root of x becomes x to the power of 1 upon 3. Cube root of x is x to the power 1 upon 3. And if I separate the fraction, this becomes x cube upon x power 1 upon 3 minus 1 upon x power 1 upon 3. Simplify further, this becomes x. 3 minus 1 upon 3 will be 8 upon 3. We know the bases are same, so powers would subtract. 3 minus 1 upon 3 will be 8 upon 3 minus x power negative 1 upon 3. Using indices, look, this is nothing new for you. You have done property algebra in your O levels, IGCSEs, and over here as well. We have used indices. Now it is in a perfect format that we want it to be. So now the derivative would become the 8 upon 3, the power 8 upon 3 will come down and multiply. So 8 upon 3, x power 8 upon 3 minus 1. 8 upon 3 minus 1 will become 5 upon 3. And again over here, negative 1 upon 3 will come down and multiply. So negative negative becomes plus 1 upon 3. And x power negative 4 upon 3. Negative 1 upon 3 minus 1. This is the answer. Any questions, anyone?
नो।
सर वहाँ मल्टीप्लाई होके x माइनस x नहीं होगा?
Yes, x cube minus x. This would go over there, multiply with minus 1. Good. Nice. So this becomes x. X times minus 1 is x. So this is 1x. And using indices, this would become 1 minus 1 upon 3 will be 2 upon 3. And so the power comes down, multiplies. So minus 2 upon 3. And the power reduces by 1. So 2 upon 3 minus 1 will become minus 1 upon 3. 2 upon 3 minus 1. Use your calculator also, okay, to solve, simplify these brackets if need be. The thing is, I am not separately differentiating this, separately in differentiation this part, separately differentiating this part. I am first of all getting the all individual terms separate simplification after using indices, and then I'm starting the differentiation, not directly. So this is something you need to note and not make the mistakes. These are very common mistakes. Okay. Now I'm going to give you people some examples to do. Okay. For this example, you people can do this one, this one, this one. Okay. I'm pausing the recording. Try the yellow ones. Okay, and then we'll discuss. Okay. So Sanchi, what's your answer for the party?
सर 10x minus 1.
Hmm. सही है. What about part F, Sanchi?
Minus 2x to the power minus 2
Hmm.
plus 10x to the power minus 3.
Nice. Good, good. Can I Mohit? E.
सर ई का मेरा जो है वो आ रहा है 16x³ माइनस 24।
16x³ minus 24.
24x सॉरी।
24x. Wait a minute. This
हाँ
would
जी हाँ जी
become
हाँ जी।
4x cube, so 16x cube and 12x square. So minus 24x. Yes, that's it. No zero. Oh, sorry. The last one would be 9. The derivative of 9 would become 0. What about h? What is the derivative here? Mohit, Mohit, कहाँ
जी
गया?
सर।
इसका भी
कौन सा
बताओ.
पार्ट?
h, last one.
एच का?
हम्म.
एच का जो है, एच कहाँ से? अच्छा, एच का जो है 3 - 5/x² प्लस 1/4x 3/2 पावर है उसकी।
-1/4 by. Oh, sorry. -1/4.
नहीं, +1/4 है, +1/4x 3/2।
हम्म. सही है. सही है संची आपकी. आपका सही है.
सर पार्ट 3 गलत था,
हम्म.
बाकी सही है।
समझ आ गया पार्ट ई.
जी।
You can expand it using the fractions, sorry, the identities. So this would become 4x power 4 minus 12x square plus 9, and then differentiate it. Expand it. So this is the answers. Good, good, good. Now this is the first, always the first thing that you would do in any of the differentiation questions. So this will take a little bit of time, but now you know the formulas to differentiate. What are the next few things? The dy by dx. Now what is actually dy by dx? Dy by dx, if you translate it into English, this would become, it is the rate of change of y with respect to x. And you have heard another thing with the same definition, and that is the gradient, isn't it? Gradient is also the rate of change of y with respect to x, and we write it change in y upon change in x. So the d over on the left side, d, and the change in y upon change in x, they're very similar. Over here in the gradient formula, what do? We have two coordinates, y2 minus y1 upon x2 minus x1. We take the x values of the two coordinates and the y values of the two coordinates. You use them in the gradient formula, you get the gradient between the 2 points. But this is dy by dx. Dy means that it's a very, 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 very small difference in y upon very, 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 very small difference in x. So that's why this is called the instantaneous rate of change. Instantaneous rate of change. For example, if you have a curve and you are trying to find the gradient at this point using this formula dy by dx, so what would you need? You would need another point which is very, very close to this point. So you have two coordinates, x1 y1 and x2 y2, and then you would use the formula of the gradient, and this would give you the line, the gradient of the line joining these 2 points, right? But this is also not very, very accurate. The closer the 2 points are, the better the gradient will be at that point. But this is the problem. The curve is always, the gradient is always changing. So if you want the instantaneous gradient at any point on this curve, this is where you go. You use the dy by dx. So what does it do? It exactly finds the gradient of the tangent at that curve on that x or y x value, like this. So you don't need 2 points. You need 2 points for this formula, y2 minus y1 upon x2 minus x1. But if you have dy by dx, you just need the dy by dx and the point at which you want the gradient. So it gives you the instantaneous rate of change, instantaneous gradient at a point. Okay. So that's why we also call it the gradient function, because this can give you the gradient of the tangent at any point of the curve. Gradient of tangent at any point of curve. This is it. So now the question over here also, they have given us find the value of dy by dx at the given point. So we would find the derivative function, we would do the dy by dx, and then we would use the x coordinate, we would substitute the value of x, and we would get the value of dy by dx at that point. And that value is the gradient at that point of the curve. So the first one, if you would find the derivative of the first one, you will get 2x, 2 comes down and multiplies, and whenever you have only x, the derivative of x would be the coefficient, which is 1, plus minus 4 minus 0, the derivative of constant is 0, and they have given you a point at which the value of x is minus 1, y is minus 2, and they want the value of dy by dx. So at x is equals to 1, the y dash value will be 2 times 1 minus 1 plus 1, which will become 3. So this is actually the gradient of the tangent at that point. So you find the dy by dx just like the usual way. You find it, and then you substitute the value of x, the value of the coordinate that they have given. You find the value of x and then substitute it there. And this is your dy by dx, the the gradient of the curve at that point. Part B, y is equals to 5 minus 2x minus 1, right? Is the question. And the point is 2 comma 4. So first we would differentiate it the usual way. So differential of a constant, it is 0. And this one, the power comes down and multiplies. So minus 2 minus 1 will become plus 2. And x would become minus 2. Minus 1 minus 1 would become minus 2. And they've given you the value of x as 2. So this becomes 2 upon 4, which will become 1 upon 2. So this is the gradient of the tangent at this point. Okay. And now they can ask you to find the equation of the tangent as well. So now you have the point of tangency. This is the point of tangency. And you have the gradient of tangent using dy by dx, which is 3. So now the equation of a tangent is a straight line, so y is equals to mx plus c. Or you can use y minus y1 is equals to mx minus x1. So y minus 2 will become plus 2. Gradient is 3, x minus 1. So y is equals to 3x minus 5. This is the equation of the tangent at this point of this curve. So let me show it to you as well. The original function was x square plus x minus 4. This is your function, and the tangent equation we have found it is y is equals to 3x minus 5. So you can see the blue line is the tangent, and the point of tangency is the same, 1 comma minus 2. So you first of all use derivative to get the gradient of the tangent at that point, and then you already have the point, and now you have the gradient as well. So you use the equation of a line and get the equation of the tangent. Tangent is a straight line, so that's why this is it. For the second part, also, what can we do? We have the gradient. So y minus, this is the point. Y minus 4 is equals to half. Gradient of tangent is half. And x minus 2. And then simplify. So half x. And this becomes minus 1 plus 4 is plus 3. This is your answer. Let me show this as well. So your function is 5 minus 2 upon x. This is your original function, and your gradient, sorry, and your equation of tangent is 0.5x plus 3. So look, you can see the point of tangency is the same. Why isn't it showing? 2 comma 4. Simple thing. So now you know that the dy by dx is the gradient of the tangent. You find that you have the point of tangency and you use the equation of a line to get the gradient. Sorry, to get the equation of the line. Okay, this is very logical. Sanchi, clear hai? All good? Mohit?
Yes,
Yes,
sir.
The next thing they can ask you to find the equation of the normal at a certain point on the curve. So we also know from coordinate geometry that the normal and the tangent, they are always perpendicular to each other. Let me Okay, I'm doing question number 6. First of all, x y is equals to 12. They're asking you to find equation of normal when x is 2. So first of all, if you make your y a subject, this becomes 12 upon x, and you find a dy by dx. So this would become 12x minus 1. So minus 1 comes down and multiplies. So that would become minus 12x power minus 2. And look, if your value of x is given to you 2, so value of dy by dx will be minus 12 upon 4, which will be minus 3. Now minus 3 is the gradient of the tangent. So whatever the curve is, let's suppose the curve is like this. The tangent is like this. This would be your tangent. And we have the gradient of this tangent, which is minus 3. Now they want the equation of the normal. The normal would be perpendicular to the tangent, like this. And we know that the tangent and the normal, if they are perpendicular, so their gradients would be negative reciprocals of each other. So this would become 1 upon 3. Your gradient of the tangent, it is minus 3. So gradient of the normal becomes negative reciprocal 1 upon 3. Because of the rule we know about the perpendicular lines. And the point of tangency, the point of the normal, and the point on the curve, it is all same, where your x is 2. And your value of y will become 6. 12 upon 2 is 6. So the point is 2 comma 6. And all three of them are intersecting at the same point. Normal, tangent, and the curve itself. So y minus 6 is equals to 1 upon 3. Then x minus 2. And then you simplify. X upon 3 minus 2 upon 3 plus 6. Which will become plus 22 upon 3. Minus 2 upon 3 plus 6 will be, yes, no, 16 upon 3. Let's check this as well. Your original function is x, y is equals to 12. And you have found this equation, y is equals to x upon 3 plus 16 upon 3. So you can see this is normal, and the point is 2 comma 6. And your tangent will be the same equation, but your gradient is minus 3. Look, so this would become y minus 6 is equals to minus 3 x minus 2. So look, all three of them are on the same point, 2 comma 6. The blue line is the tangent, the red line is normal, and the point is 2 comma 6, the same. So all three of them are connected, normal, tangent, and the curve itself. The only one more step that you have to do is the to find the gradient of the normal, which is the negative reciprocal of the gradient of the tangent. Okay, any questions, Sanjeev? Okay, the last formula to learn of differentiation. Now we have done the basics of differentiation, the basic formula ones, and now you know what is actually dy by dx, and how can you get the equation of tangent, how can you get the equation of normal. The last thing for today's class is to learn the last formula, which goes something like this. If you have y is equals to whatever is inside the bracket, it can be anything, bracket close power n, and now they're asking you to differentiate this. Whatever is inside the bracket doesn't matter. So what happens, the derivative will be, the power again will come down the same way, the bracket doesn't change, and the power reduces by 1, and then you also write down the derivative of the inside. This is your the most complicated one for you. And for an example, if you have y is equals to, let's suppose 2x minus 3 power 6. Look, there's a bracket and there's something inside the bracket. Bracket is raised to the power 6, and now they're asking you to differentiate this thing. So the derivative will be no difference to the bracket. Inside the bracket it's everything same. So 6 comes down, then multiplies. So 6 comes down, 2x minus 3. The power reduces by 1, so 6 becomes 5. And then the derivative of the inside, derivative of 2x minus 3 will become 2 only, because 3 is a constant, so 0. 2x becomes 2, 3 is a constant, so that becomes 0. So this is your final answer. This is the derivative. If you want to simplify, this becomes 12, 2x minus 3 power 5. This is your answer. Okay, let's do some more examples. 3 upon x minus 5, let's suppose. So first of all, bring the complete denominator up. So this becomes 3 multiplied by x minus 5 power minus 1. And now you can differentiate it. So minus 1 power comes down and multiplies with 3. So this becomes minus 3. X minus 5 power reduces by 1. So minus 1 minus 1 minus 2. And the derivative of x minus 5, 1 minus 0. So your final answer is minus 3 x minus 5 power minus 2. Let's do 2, 3, 1 or 2 more examples. Under root 2x square minus 1. Okay. Y is equals to 2x square minus 1. So what happens to this? First simplify. 2x square minus 1 power half. Now differentiate. Half power comes down. No difference inside the bracket. Power reduces by 1. Half minus 1 will become minus half. And then the derivative of the inside. 2x square minus 1 will become 4x minus 0. And then if you want to simplify, this would become 4x upon 2. 2x square minus 1 power negative half. This and this cancel out. This is the final answer. Okay? Copy this down as well. If you have any questions, ask. We will do more things as well. But I'll share you this worksheet so that you can do the differentiation part where you just do the practice how to differentiate. There are still more things to do. This topic is not over.